All right, so now let's get into the second half of the last section of Unit 4. So far in the last two sections, we've talked about parallel and perpendicular lines. And in the beginning of this section, we talked about how to write the equation of a line. So now we're going to combine those two concepts together, and we're going to be writing equations of both perpendicular lines and parallel lines. So let's get into it. So we're asked to write the equation of a line that is passing through the point 2, 3, and is perpendicular to the line y is equal to negative 2x plus 2. Okay, so they're asking a lot out of us, so let's take it little by little. So first, they ask us to find the slope of a line that is perpendicular to this line. Okay, so remember from 4.3 that perpendicular lines have slopes that are opposite reciprocals. Okay, so let's first determine what is the slope of our new line going to be. So if it's going to be perpendicular to this line, and this line has a slope of negative 2, we have to think what is the opposite reciprocal of negative 2. Okay, so opposite tells me change the sign, so it's going to be positive, and then 2 can also be rewritten as 2 over 1. So basically, I'm going to flip that, and it's going to be 1 over 2. So my slope of my perpendicular line will be 1/2. So now from there, I need to figure out what my y-intercept is, and I can do that by using the slope and then the point that I am given. Okay, now there's different strategies you can go about doing. You can use point-slope form if you want to, or if you would rather, you can use the slope-intercept form, and here's how we're going to do it. So we need to find our y-intercept. So far, we've got a couple pieces. So if we recognize slope-intercept form is y is equal to mx plus b. Well, we have a y, 3. We have an x, 2. We have an m, 1/2. The thing we don't have is a b. So I can plug in the three things that I do have, and then I have just a multi-step equation with one variable that I can solve pretty quickly. So I plug in y, m, and x, and I leave b alone because I don't have anything for b. So I have 3 is equal to 1/2 times 2 plus b, and now I'm going to solve for b. So 1/2 times 2 will give me 1, so I have 3 is equal to 1 plus b, subtract the 1, and I get that b is equal to 2. Okay, so that is going to be my y-intercept. So now I'm going to combine my two pieces. I've got my slope, I've got my y-intercept, so I'm going to write my equation in slope-intercept form. Y is equal to 1/2 x plus 2. And then I went ahead and graphed both lines as well. Okay, so this first line right here, this is my original, negative 2x plus 2. And then this line right here is the one that I just discovered, 1/2 x plus 2. And you can see that they do, in fact, intersect at that point right there, at their y-intercepts. And these two lines, they do intersect in such a way that right angles have been created. Okay, so now let's talk about how to write the equation of a parallel line. Adjust my camera here. Okay, so writing the equation of a parallel line. So write the equation of a parallel line passing through the point negative 1, 1 that is parallel to the line y is equal to 2x minus 3. So we're going to go through a similar process that we did with the perpendicular line. So first, I need to determine what is the slope of my parallel line going to be. So recall from 4.3 that parallel lines have to have the same slope. So if the slope of my first line is 2, the slope of my new line must be 2 as well. So now I need to go through and I need to find the y-intercept by using my slope and then my point. Okay, so on the last one I did use slope-intercept form. That's completely fine. You can use that one for this one as well. I decided I wanted to show y'all an alternate way that we could also do it. So this time I used point-slope form instead. So point-slope form originally looks like y minus y1 is equal to m times x minus x1. So if you got a slope and then any random point that's on the line, you can plug those in and eventually work your way down in a slope-intercept form. So this first y I'm going to leave alone, minus my y over here, 1, so I have y minus 1, is equal to m is 2, times x minus negative 1. So x minus negative 1 will turn into x plus 1. So this is my first setup. Now, eventually, I want to work my way down in slope-intercept form because it's a lot easier for us to graph equations if they're already in slope-intercept form. A little bit harder if we're trying to do it in point-slope form. So distribute my 2. I wind up with y minus 1 is equal to 2x plus 2. Add my 1 over. I get y is equal to 2x plus 3. And so that is going to be my new equation of my line. So I've got this for my equation, so I'm going to go ahead and graph it. Okay, so this bottom one is my original, y is equal to 2x minus 3. This top one is my new one, y is equal to 2x plus 3. Okay, so now we kind of understand the basics of it. Let's go through and let's do a couple more examples on the next foldable. All right, so let's look at this foldable. So we're going to write, we got 2 examples of writing parallel lines and then 2 of writing perpendicular. So let's get started. First example, write an equation in slope-intercept form for the line that passes through the point 6, 2 and is parallel to the line y is equal to negative 2/3 x plus 1. And then we need to graph both lines. Okay, so we need to find the equation of a line that is parallel to this one. So first off, I need to know my slope. So parallel lines have the same slope. The slope of this one is negative 2/3. So that's going to be my new slope. So now I need to determine what is my y-intercept. Well, I've got a slope, I've got an x, and I've got a y. So I'm going to plug those into slope-intercept form. Again, you can use point slope if you want to. I'm just going to use slope-intercept. It's a little bit easier for me to use. So I'll plug it in. So y2 is equal to negative 2/3, which is my m, times 6, which is my x, plus b. Now I'm just going to solve for b. Negative 2/3 times 6 will give me negative 4. Add my 4 over, and I get b is equal to 6. So my parallel line is going to be y is equal to negative 2/3 x plus 6. And then I graph both of them just to show that they are parallel. So this bottom one is my original. This top one is the one that I found. Okay, let's look at another example. Write an equation in slope-intercept form for a line parallel to y is equal to negative 3/4 x plus 3, and this line is going to contain the point negative 8, 6. So again, talking about writing an equation for a line that is parallel to this one. Parallel lines have the same slope, so my slope must be negative 3/4, which I wrote here. Need to figure out what my y-intercept is, so I'm going to use slope-intercept form, and I'm going to plug in my values for y, m, and x. So y6 is equal to m, negative 3/4, times x, negative 8, plus b. Negative 3/4 times negative 8 is 6, so I have 6 equals 6 plus b. Subtract the 6, 0 equals b. Okay, so if my 0 equals b, I just have my equation as just y is equal to negative 3/4 x. You can add the negative 3/4 x plus 0 if you want to, but if you don't, it's understood. Okay, so then I just go through and graph. This top line is my original. This bottom line is the one that I discovered. Okay, so now let's change gears. Let's talk about perpendicular lines. All right, so perpendicular lines. So let's look at example 3. Write an equation in slope-intercept form for a line perpendicular to y is equal to negative 3x plus 2, and it contains the point 6, 0. Well, so I'm looking this time for lines that are perpendicular. And recall from 4.3 that perpendicular lines have slopes that are opposite reciprocals, which just means change the sign, flip the fraction. Okay? So we have negative 3, so it's going to be positive 3. And then flip the fraction, 3 over 1 flips to 1 over 3. So my slope will be positive 1 over 3. So now to determine what my y-intercept will be, I'm going to take my values for y, m, and x and plug them in. So y is equal to 0, m is equal to 1/3, 6 is equal to x. Multiply those together, 0 is equal to 2 plus b, and subtract the 2 over, and I get negative 2 for my b. So my slope is 1/3. My y-intercept is negative 2, so my equation, y is equal to 1/3 x minus 2. And then I graph both my lines to prove they are perpendicular. So this line right here is my original, y equals negative 3x plus 2. This line right here is my new line, 1/3 x minus 2. And when they intersect, they do indeed create right angles. Okay, let's look at one last example. Okay, so example 4. Write an equation in slope-intercept form for the line that passes through the point negative 10, 2 and is perpendicular to y equals negative 5x plus 8. So, perpendicular lines, got to figure out our slope first. So my original slope is negative 5x. I need a slope that is the opposite reciprocal of negative 5. So, change the sign, flip the fraction. My new slope will be 1/5. Need to figure out what my y-intercept is now. So, plug it into slope-intercept form. Plug in your values for y, m, and x that you already have. So 2 is equal to 1/5 times negative 10 plus b. Multiply these together, you get 2 is equal to negative 2 plus b. Add the 2, you get 4 is equal to b. So slope of 1/5, y-intercept of 4. Your equation is y is equal to 1/5 x plus 4. And then just to verify, let's come over here and graph it. So this line right here is my original, negative 5x plus 8. This line here is my new line, 1/5 x plus 4. And they do indeed create right angles. So these lines are perpendicular to one another.